Hi, it's Dr. Robin, aka Double O Pi. In this video, I'm going to give you a brief introduction to UV visible spectroscopy, just enough that you can understand what's going on in lab if you're using a UV vis spectrometer. We won't get into the theory behind molecular absorption spectroscopy. This is meant to be a very brief introduction. So what is absorption spectroscopy? To understand, we need to begin by thinking about two different words: spectroscopy and spectrometry. Both of these words start with the root spectro, which comes from the root word spectrum. Now, when you think of the word spectrum, you might think about light that's gone through a prism, something like this. But the spectrum actually encompasses electromagnetic radiation of many wavelengths, most of which we can't see. When we talk about spectroscopy, we are talking about starting with some sort of electromagnetic radiation and looking, that's the scope part, at what happens when it interacts with matter. You may also hear the word spectrometry. That's a similar concept, but in this case, we're not just looking at these interactions, we're actually doing measurements to help us get quantitative data. So spectroscopy is qualitative and spectrometry is quantitative. Most spectroscopic instruments can do both qualitative analysis, telling us what's there, as well as quantitative analysis, telling us how much is there. So a lot of times you'll hear chemists use spectroscopy and spectrometry interchangeably. For purposes of this video, we are going to be talking about absorption spectroscopy, and very specifically about UV visible absorption spectroscopy. Let's talk about those terms now. In absorption spectroscopy, we compare the amount of light that is directed towards a sample with the amount of light that actually comes out the other side. Sometimes the amount you put in is exactly the same as the amount that comes out, but that's pretty rare. Usually, only some of the light comes out.
What happens to the light that doesn't come out? The simplistic answer is that it gets absorbed through interaction with the molecules in the sample that you're measuring. To give a little more detail, some of the photons of light that are passing through your sample will not interact with molecules at all. After all, most of a substance is empty space. But even if a photon does hit a molecule, it will only be absorbed if it has the right wavelength to interact with that molecule.
Again, I'm not going to talk about the theory behind why molecules absorb light in this video. If you're interested, I've linked to a longer discussion of theory in the description below. So now that you have an idea of what it means to look at absorption spectroscopy, let's talk about UV visible absorption spectroscopy in particular. To do this, we have to go back to the spectrum again. You can see here that the spectrum is broken into sections: gamma rays, X-rays, ultraviolet, visible, infrared, and radio waves. Maybe you've wondered why people chunk the spectrum the way they do. For the most part, these distinctions have to do with how these types of electromagnetic radiation interact with matter. Most spectra show ultraviolet and visible radiation as separate chunks, but they really belong together. Why? Because both UV and visible light interact with matter the same way. So why do we separate them then? Because our built-in spectroscopes, our eyes, can detect visible light, but not UV light. From a human perspective, it makes sense to separate them. From a scientific perspective, it doesn't. So UV visible absorption spectroscopy involves looking at how much ultraviolet or visible light gets absorbed when you pass it through a sample. Sometimes when you use UV vis, you'll be looking at a single wavelength of light and how it interacts with your sample. Other times you'll be looking at how much gets absorbed at each wavelength throughout the ultraviolet and visible spectrum. So I've explained the basics of UV visible spectroscopy, but how do we use it to do quantitative work? In other words, how do we actually measure how much of a substance we have? In general, the more substance there is for the light to interact with, the more light will be absorbed. If you want to find out more details on how to do this, please check out my Beer's Law video, linked here, I think. Do you have any questions? If so, leave them in the comments below and I'll try to address them in a future video. Thanks for watching. I look forward to seeing you again soon.